Today's asynchronous session is on solving equations, one-step and two-step linear equations. All right, so our objectives are to be able to solve those type of equations with decimal numbers, fractional numbers, and whole numbers, both with one-step and two-step equations. And we're going to learn what an inverse operation is. Here are some key terms associated with this unit that are all listed in your table of content dictionary. If you don't know what any of these mean, look them up and we'll talk about them as we go through the lesson. First of all, let's talk about what an inverse operation is. What is it we're doing when we're solving equations using inverse operations? What should I do first? What should I do second? Well, let's think of a non-math example. I want you to take a look at these jars. Take a look at the jar in the middle. All right? I want you to think about what would have to be done, right? If somebody were to give you an empty mason jar, what steps would you have to take to fill these beans in this jar in this order, or these seeds? What would you have to do? Then I want you to think, what steps would have to be taken for you to get at these orange seeds on the bottom of this mason jar? Take a moment and think about that. Well, it's not too hard to see. If I gave you an empty mason jar with the lid on it, to fill it up with these seeds, you would first have to unscrew the lid. Then you would have to put in the orange seeds, then these white seeds, then these gray seeds, and then finally the yellow ones, and then you screwed the lid back on. So what if I were to undo that, if I were to do the opposite of that, the inverse of that? I want you to think what steps you would do and what order you would do them in. The whole idea is what you're supposed to come to the conclusion is that you end up doing the opposite step in the opposite order. So if I want to get at these orange seeds, the very first thing I'm going to have to do is unscrew the lid. Remember, the last thing we did was screw the lid on after we put the seeds in. So now I undo that by unscrewing the lid. Then I would have to take out the yellow seeds. Then I would have to take out the gray seeds, and then the white seeds, and then finally I would be at the orange seeds. Remember, the orange seeds were the first seeds I put in. Now they're the last seeds that I take out. So you end up doing the opposite step in the opposite order. And that's exactly what we're doing in math when we're solving these equations. We end up doing the opposite step in the opposite order. And by step is what we're talking about is the order of operations. Okay? So let's first of all take a look at solving a one-step equation. All right? One-step equations are called one-step because they literally only have one step to solve them. So in this example, we have 4.2 times x equals 12.6. And we need to get the x all by itself. In this case, it's on the left-hand side of the equation. Right? So there's the variable. So what we need to do is move that 4.2 away from the x. If we want to isolate x, that means get it all by itself, we need to get that 4.2 away from it. All right, remember 4.2x does mean 4.2 times x, times some number. So what we're trying to undo here is multiplication. And we undo that by doing the opposite of multiplication, which is division. So in this case, we need to divide both sides of the equation by 4.2. The reason that isolates x on the left is because 4.2 times 4 divided by 4.2 is 1. And 1 times x is just x. So we can think about it as just the 4.2's canceling out, because that is the opposite, the inverse operation. That's why we chose to divide by 4.2, so that would happen. And so what we do to one side of the equation, we have to do to the other side of the equation to keep it balanced. So we go ahead and we get on our calculator, and we go 12.6 divided by 4.2, and we get 3. Think about this in terms of undoing the steps in the opposite order, like what we just had with the mason jars. Suppose I told you a number for x. So you have a number for x. The very first thing you would do according to the order of operations is multiply it by 4.2. And that's the only step we had. So we only have one step to undo, the opposite of multiply by 4.2, which is, of course, is divide by 4.2. So take a moment and see if you can work this problem out. 8.8 times y equals 36.4. All right, so start off by thinking what is being done to the variable. And in this case, the variable is y, and it is being multiplied by 8.8. So again, we only have one step to get the variable by itself. Since it's being multiplied by 8.8, all we need to do is divide both sides by 8.8. Okay, so on this side, the 8.8s cancel out, leaving you just y. And then y is equal to 36.4 divided by 8.8. And yes, you could work that out longhand, or you can also go on your calculator and work that out. And if you do that, you get that 36.4 divided by 8.8 is equal to, do it real quick here, is equal to 4.13, right, 4.1363 repeating. And then suppose I just want to round that to the nearest hundredth place. That means the two places after the decimal. So I'm going to go ahead and round this and say that that's about 4.1. Let's see, I look to the neighbor to the right of the 3 and it's a 6. That's 5 or more, so I'm going to round the 3 up to a 4. Here's an example of another one-step equation, this one involving addition. Again, identify the variable, in this case n, and ask yourself what's being done to n. What do I have to undo? And n here is still being added to 8.2, and this is a positive 8.2. So I'm going to go ahead and do the opposite of adding 8.2, which is subtracting both sides by 8.2. So I'm going to subtract 8.2 from both sides of the equation. And then we're going to get that n is equal to, using the rules for addition and subtraction of integers, when the signs are the same, we add the numbers. So I would get 12.7, and we keep their sign. So negative 4.5 and a minus 8.2, when I add them together, I get negative 12.7. Again, just one step to do that. So take a moment and think to yourself, what is being done to the variable x in this case, and how do you undo it? What do we need to undo? All right, so when we have a variable being divided by 7.1, so we can see here that to undo this division, because that's what that little bar means, it does mean divide. To undo dividing by 7.1, we need to multiply both sides by 7.1. We multiply this side by 7.1. So you'll notice that as you go on and progress through your careers in math in high school and beyond, that we often don't write the time symbol anymore. We'll put parentheses and put the number right next to it. That indicates multiplication. So when I write it like this, you know, the 7.1s here will both cancel. And this does mean 4 times 7.1. All right, so you could always check that on a calculator, 4 times 7.1. And we get that our answer is 28.4. All right, and that's a positive 28.4, so make sure to keep track of your signs. Again, it was just one step. Hey, I want to get the variable by itself. I need to kick this 7.1 over to the right-hand side. Oh, well, right now it's showing me division. I just do the opposite, multiply, done. One step, right? Pretty easy. So again, here we're working with fractions in this case, but the steps we have to do are exactly the same. I think you notice now that we're just undoing it by doing the opposite of, in this case, subtract. Or if we have divide, we're undoing it with the opposite of multiply. If we have something being multiplied, we undo it with division. It doesn't matter what kind of number we're working with. A whole number, a decimal, a fraction. That step doesn't change. All right? It's just working with the numbers that might get a little bit complicated, but again, you can always check that on a calculator. So in this case, here's this fraction, here's our variable x, and we're subtracting 2/9 from it. So I want to do the opposite of subtract 2/9, which is to add 2/9 to both sides. So it's the same thing, adding 2/9 to both sides. Now if you want to write this up here, right next to it, you can. In fact, a lot of books will show it that way. It's the same thing as long as we know that we're adding 2/9 to both sides of this equation. So over here, a negative 2/9 and a positive 2/9 cancel and give you 0. So we get just x on the left-hand side. And now now I'm looking at my fractions, and we are adding fractions here. So the first thing I have to check is that I have a common denominator. In this case, we do. It's what I like to see, so that makes it easy for us. We already have a common denominator of 9. And now this negative, I apply that to the numerator. So I do think of that as -5. So I have -5 plus 2. And -5 plus 2 is -3. All right? So here we get -3. So we have, sorry, excuse me, that's a 2. So we get -3 divided by 9, and that can reduce. 3 and 9 have both a common factor of 3, so I can divide both the numerator and the denominator by 3. So I end up with -1 over 3, and that is a simplified fraction. All right, so one more example with fractions and multiplying in this case. So right here, I identify the variable y, and I ask what's being done to this variable. Well, it's being multiplied by this fraction 5/11. So that's what it means when I write them right next to each other. So the way I'm going to do this, and why it's called a one-step equation, is because to undo multiplication by a fraction, we can multiply both sides by the reciprocal. And reciprocal is just a fancy word for saying take the fraction and flip it over, flip it upside down. So notice that what was in the denominator, the 11, is now in the numerator. And what was in the top of this fraction, the numerator, is now in the denominator, the bottom. So I just flipped it over. And I multiply both sides by that fraction. So remember, to undo multiplication by a fraction, just multiply by its reciprocal. The reason why that helps us is I have a 5 here in the top of this fraction and a 5 in the bottom of this fraction. They cancel out. The 11s, by the same thinking, will also cancel out. Or you could think of this as 55 divided by 55, which is 1. 1 times y just gives you y. Now finally we have a fraction. This is -4/3. So I apply this negative sign to the numerator of my fraction. And I go ahead and I multiply straight across. When we're multiplying or dividing fractions, we don't need a common denominator. So now -4 times 11 is -44. And 13 times 5 is 65. And just to make sure, I try to check if I have any common factors between the 44 and 65, just to make sure that I can't reduce this fraction anymore, that it's in simplest forms. And the only thing that goes into 44 is like 2 and 4 and 11. And in 65, only 13 and 5. So there's no common factors between these two numbers, so I can't reduce it anymore. So it is in lowest terms. So our final answer is -44 over 65. Now let's do a two-step example. So as you may have guessed, we call them a two-step equation because they always take exactly 2 steps to solve them. So let's talk about solving this equation for x. Here we have 2.5x minus 2 equals 17.5. So think back to our example again with the mason jars. And ask yourself, if I were to give you a number for x, according to the order of operations, what would be done to the x? So suppose I said let x be 2. And let's not even look at the right-hand side of this equation. Let's just say I had the expression 2x minus 5, 2.5x minus 2. And I told you x was 3. So if I plugged in an x, 3 where the x was, according to the operations, I would first multiply it by 2.5 because we have to do multiply before add and subtract. And then I would subtract 2. So again, if I knew what x was, I would multiply it by the 2.5 and then subtract 2. So now that I want to undo that and get x by itself, we need to undo those steps in the opposite order. And we need to do the opposite thing in the opposite order. So remember, the last thing we would do here is subtract 2. So that implies that the first thing I need to do to get x by itself is add 2. Then remember, the first thing we did was multiply by 2.5. So the last thing I should do when I'm solving for x here is then divide by 2.5. So again, here's the variable. We can see what's being done to it. We talked about that. And then 2 is being subtracted, so that needs to be undone by addition. And then we have to decide what our first step is. And so there's a few ways to think about it. If you think about kind of like a picture, you can say this 2.5x that's together, they're right next to each other, that's a term. And where we have this minus 2, that's another term. Terms are things that are separated by pluses or minuses. All right, so I want to first isolate the term that has the variable. In this case, that's the 2.5x. I want to get that by itself first. And in order to do that, we're going to add the 2 to both sides. So we break that piece apart first. And we do the opposite, so we add 2. So we get that 2.5x is equal to 19.5. Now we're back to a one-step equation, which we've seen plenty of examples of. So what's being done to x? Well, it's being multiplied by 2.5. So we need to undo that with division. So we go ahead and divide both sides by 2.5. And 19.5 divided by 2.5 is 7.8. You can always check any of these answers that you get to make sure they work. The way that I would check it is I would take our 7.8 and I would replace the x with that in our original equation. I'd pull out my calculator and I'd go 2.5 multiplied by 7.8, then I would subtract 2 and make sure that I got 17.5. So let's try this two-step equation. Take a moment to pause the video and try to work it out on your own. So the first thing we have to decide is what should I do first? We know there's 2 steps to solving it. What should I do first? So remember, you're trying to isolate the term with the variable. And this is a term, right? When they're written next to each other, we call that a single term. It's like a whole group. And my other term over here is the minus 4. So to get this term by itself, to get the 6n term by itself, I need to get rid of this minus 4. All right, so my first step then is going to be to add 4 to both sides of this equation. All right, so I'm going to add 4. I'm going to add 4 to the right-hand side. So that finally now we have 6n isolated, that term on the left-hand side. And we add 32 and 4 and get 36. And voila, we're back at our one-step equation. So we undo multiplying by 6 by dividing both sides by 6. And then we get that 36 divided by 6 is 6. Let's figure out what 2 steps we need to do to solve this equation. All right, so in this case, we want to isolate the term with the variable y. And notice how these are connected. They're not separated with a plus or a minus. That's what makes it a term. So in this case, I'm going to go ahead and I need to undo subtracting 6. That's what I need to do the opposite of. So in this case, I need to add 6 to both sides. A minus 6 and a plus 6 is 0. And then now y divided by 2 is equal to 14. And then now we're back to our one-step equation. So ask yourself what's being done to the variable here on the left. Well, we're taking the variable y and we're dividing it by 2. So we need to undo division by 2. And to undo dividing by 2, the opposite of that is to multiply both sides by 2. Alright, so in this case, the 2's will cancel out on the left, giving us y by itself, and 14 times 2 is 28. Does the steps change if I have fractions? The answer is no. Alright, so I'm still trying to isolate the variable. And so I identify the variable, and I see that it is with this negative 3.2 right next to each other. So that's a term. I need to isolate that term with the variable first. So I'm going to get rid of adding 12.7 because that's what's with the variable on the left-hand side of this equation that I'm trying to isolate. So I'm going to do the opposite of adding 12.7, which is to subtract 12.7 from both sides. Alright, so then on the left-hand side here, we only have negative 3.2 multiplied by b is equal to, and I know that's a little hard to write there, but it's negative 12.7. So again, when we have the same signs and we're adding and subtracting, the rule is that we add the numbers. So I pull out my calculator and I say 12.7, and I go ahead and I add that to 5.34. And I get that the answer is 18.04. And then I keep the sign. They're both negative, so I keep the sign that they both are. So when we're adding two negative numbers, it's kind of like we get a bigger negative number, absolute value-wise. Okay, again, let's go ahead and rearrange the terms from the type of problem we had before. So in this case, we're still trying to isolate the variable k. All right, so we look where the k is, and I notice that it is grouped with this 13, that k is being divided by 13. That's a term, right? Because remember, separate terms are separated by pluses and minuses. So it's this negative 2, it's this guy here that's at the end that I want to break off, that I want to undo first. And I go ahead and I do the opposite of whatever sign is to the left. So this is a negative 2. So I'm going to add 2. So remember, always look to the left to figure out what that number sign is, and you're doing the opposite of that. I'm not doing the opposite of this addition in the middle. So now if I added 2 to this side, I have to add 2 to the right side. Another way to know that this was the correct step to do was to add 2 instead of subtract 2, is because a minus 2 and a plus 2 is 0. That's what makes it cancel out. That's what makes it goes away. The only thing that I have left then is k divided by 13. In this case is equal to 5, because 3 plus 2 is 5. And then now we're back at our one-step equation. Well, I got to get k by itself. I got to do the opposite of division, because k is being divided by 13 here, so I'm going to go ahead and multiply both sides by 13. All right, and then we get that 5 times 13 is 65. All right, so these are some practice questions, but these questions are going to be included in your asynchronous questions, which can be found in the course announcements under asynchronous session 3. Or sorry, excuse me, asynchronous session 2. So go on to your course announcements and then finish the questions. They're listed underneath the video. And if you have any questions, again, you can always call me. My number at my desk is 480-648-0861.